Let's say we have now the function y equals 3 to the x. We want to know what the derivative of this function y equals 3 to the x is. We know that we can't apply the power function rule because it's not something like x to the third. X is not the base, x is the exponent. This is an exponential function. Well, in order to understand this derivative, we actually need to use something called the chain rule for composite functions. Your textbook does a little bit of hand-waving about this and actually does a pretty good job of making a convincing argument. I'm going to give a slightly different version that actually kind of invokes the chain rule. It all comes down to the same thing, okay? I'm going to say that 3 to the x is nothing but e to the x times the natural log of 3. How could I possibly say such a thing? Well, let's think about it. E to the natural log of 3 is just what? E to the natural log of 3 is 3. That's your basic definition. Exponential and natural log functions are inverse functions to one another. If you don't remember this, you'd better go back and review exponential and logarithmic functions and the laws of logarithms. Okay, that's very important. It's very important for you to know that. Now, so e to the natural log of 3 is just 3. And if we raise e to the natural log of 3 to the x power, then we've got 3 to the x. Of course, another property of exponentials is that a power of a power, we just multiply the power so that this is nothing but e to the x times natural log of 3. Now, knowing that, and let's just summarize that up here. Okay, y equals 3 to the x means that y is e to the x natural log of 3. Then the derivative of y has to be, and this kind of invokes, this actually does invoke the chain rule, or something equivalent to it. When we take the derivative of e to the x natural log of 3, we don't get e to the x natural log of 3 as we might expect, since the derivative of e to the x is e to the x. We get natural log of 3 times e to the x natural log 3. Okay? Now you can store that away. We'll see shortly why that's true, and this will become second nature. But we simply correct for the fact that this is 3 to the x and not e to the x by bringing a natural log 3 out in front. Notice when we do that, we don't get rid of the natural log 3 here. We keep the same exponent, but we do put another natural log 3 out in front, so that y prime is natural log of 3 multiplied by 3 to the x. We can generalize this to any function. If we have y equals a to the x, then we're going to say that y prime is natural log of a times a to the x. Just in the same way that the derivative of 3 to the x is natural log of 3 times 3 to the x.